Hello everyone, this question is about complex numbers. So we have the u and the w in exponential form. Find u squared over w. So from the 2e to the power of 1/4 pi I, we know that the r, or the modulus, is 2 and the theta is 1/4 pi. And from this we know that the modulus is 3 and the theta is 1/3 pi. Now when we're finding the modulus of u squared over w, we simply use the modulus of u and we square it divided by the modulus of w. Okay, so it's just 2 squared divided by 3, which is 4 over 3. Now for the argument, we have to so u squared here means we have to multiply u times u, which means for the argument we add, and for division we subtract the argument. So 2 times the argument of u minus the argument of w. So use a calculator and you get this, which means the final answer is the modulus, this is the argument. All right. State the least positive integer n such that both the imaginary of w to the power of n equals 0 and the real part is positive. So w from the previous part is this is w. Okay, so this length is 3 and this angle is 1/3 pi. So if you just try some possible powers, so maybe the n is 2. If the n is 2, you have to square the modulus. The 3 to the power of 2 is 9, and you multiply the argument by 2, so 2/3 pi. So as you can see here, the imaginary part is not 0, of course, because we have some imaginary part here. Now if the n is 3, so we're gonna get 3 to the power of 3 for the length, which is 27, and 3 times 1/3 pi, which is pi. So in this case, the imaginary part is 0. So this is true here. Unfortunately, the real part is negative, because obviously this is minus 27 actually. Okay, so the length is 27 to the left, so it's minus 27. So to get positive real value, of course, actually we have to use w to the power of 6 if you just look at the pattern. So when the n is 6, we use the length 3 to the power of 6, and for the angle, well, 1/3 pi times 6 is 2 pi. So this is w to the power of 6. There is no imaginary part and the real value is positive. So the answer is the n must be 6. Alright, I'll see you again next time.